Well, hello everyone, and welcome back to Adrian's Digital Basement. On a recent video, I checked out this Hantek 2-channel 20 megahertz oscilloscope, which costs a whopping $60 shipped. And I wanted to find out if it was any good for repairing an old 8-bit computer. I tested it out on a Commodore 64, and while it's not perfect, it has a few issues, it definitely does the job. So check out that video. I'll put a link in the description below if you haven't seen that already. Today we're going to be checking this out though. This is a Hantek battery-powered 2-channel oscilloscope with a multimeter built into it, and it costs about $130 shipped. Your price may vary a little bit depending on if you get it on sale or there's a coupon, but overall it's certainly twice the price of this one, but it might be pretty capable. And of course, being standalone, I don't even think it needs a computer. So without further ado, let's check it out. All right, here it is. This is the Hantek 2C42. And this is the listing for it on AliExpress. And I bought this exact model right here. Seems to be $122 right now with $12.22 shipping. And I look back through my orders and I paid $114.24. And I recall the shipping was about the same. As I had mentioned in my last video, I ended up ordering 3 different Hantek inexpensive scopes, and this one was actually the most expensive of the 3, but I thought this one seemed pretty interesting because I actually don't have a battery-powered scope right now, and if this is at all capable, it might be useful for me to have in my arsenal of tools. Not to mention, this scope is definitely more than twice the price of the last scope that I took a look at, but I think it might also be quite a bit more capable. Taking a look at the specs on here, there are 2 versions, a 40 and a 70 megahertz one, and the 42 in the model number here represents 40 megahertz with 2 channels. And I don't know what the difference between the D and the C one is, but there's also a 70 megahertz version and also the C and the D variant. There are loads of very inexpensive little standalone oscilloscopes with LCD screens on them. I would avoid all of them unless it's starting to get up into the $90, $100, $120 range. When I was doing my searching around, that seemed to be the sweet spot where you start to get a device that was actually fully functional and capable of being a proper oscilloscope and actually had decent bandwidth. All right, so back at the listing, some of the things that seem really cool about this thing is obviously a newer design. It's Type C, and it seems to have 2 hours of battery life, so not great, but it must have a built-in lithium-ion battery for charging up, so that's a plus. While I unwrap this from the box, this is exactly how it came shipped. I have not looked inside here, so let's take a look at what we got. All right, so right off the bat, I'm loving that this thing came with a carrying case. Here's the actual unit itself. Let's just quickly look at what else is in here. USB charger. It does have a US plug, so that's kind of cool. USB-C to A. Okay, makes sense. For a second, I was like, wait a second. Don't tell me this has an A port on it, but this obviously has a C port on it. And then we have some test leads. I'll just quickly unbox these or unbag them. Let's see if these are cheap plastic or what. I'm not expecting them to be super amazing. Yeah, I wouldn't call these silicone. They're soft, but they're a little hard. I mean, nothing amazing. Probes are pretty sharp though, so that's nice. But these are standard. You could just replace these with anything. All right, we have this, which is a BNC to just standard clip leads. Now you wouldn't use this for any kind of high frequency measurement, and I have another one somewhere around here that I think I cut these clip leads off and attached little J hooks to, little hooks, because those are more useful to me. These are useful if you're just trying to hook up to like an audio output or something, but you definitely never want to use this for anything that's high frequency. Okay, and the last thing is there is one oscilloscope probe in here, which looks to be exactly the same as the one that I got with the $60 scope. And I actually have that probe sitting right here on the bench because I've been using it with my virtual bench. And these probes, while cheap, work perfectly well for low frequency applications. I mean low when I'm talking 10, 20, 30 megahertz. They say they're rated to 80 megahertz, but I have no complaints about these. These, for inexpensive devices, really work well. Now, it's sucky that this 2-channel thing only came with 1 probe, so it would have been nice for the price if they had actually included 2. So here is the main unit, and right off the bat, I'm pretty impressed. It feels really solid, really good build quality, not cheap feeling at all. On the outside of the machine, and it's just black, it's kind of a rubber grippy texture. Now this is hard plastic. This will be the tilting bale here, which feels a little crappy. Well, there we go. No, okay, it just clips like that. Okay, that's fine. Anyways, yeah, it's nice and rubbery, and it has a raised lip around the screen. So if you drop this face down, you're not gonna have any problem. The BNC jacks there, the inputs are recessed. And looks like, what do we have here? Ooh, we have channel 1, channel 2, and function generator output. Oh, now I didn't opt for the function generator because I think it was a little bit more expensive. Let's see. Okay, $150. So, you know, it's really not much more, but that was still like almost $30 more. And personally, I don't need a function generator, but if you don't have a function generator, that's pretty decent. Now, why exactly is the function generator output on here when I bought the version without? Let's see if we see a model number on here somewhere. I don't see a model number. I really wish this wasn't so like clicky, breaky feeling, but guess it's not the end of the world. All right, what do we have here? So there's a little cover, which is really hard to take off. And there's a USB Type-C there. Let's peel this sticker off the screen. Yeah, there we go. Look at that. All right, let's power this thing up. I would hope it's charged, but maybe not. Okay, it's not turning on. Let me grab a power bank to plug this in. I am going to try out the included USB cable. Look how long and funky this is. That's kind of cool in a way. Let's plug that in. Nope. And I have a little meter here so I can see if it's definitely drawing a current. Turn that on. Oh, there we go, powered up. Okay. All right, so we're drawing 320 milliamps. So not a lot. Don't know if it's actually charging. All right, so there it is. The screen is very dim. There's a backlight setting here. Let's just max that out. Goes 1 to 10. I'm gonna max that out for the video. It's actually not that dim when you look straight on, but I'm trying to angle it so the camera can see it. All right, so right off the bat, we have a couple backlit buttons. The power one is red, and then this is the run stop button. It goes between green and red, so I kind of like that. It's nice and bright. Down at the bottom, we have the inputs for the multimeter. It's all pretty standard affair. We have some function buttons, scope, DMM, AWG, which I'm not sure what that means. Menu, there's a person button, which maybe means like profile, trigger, auto enter, channel time, up, down, left, right, and then of course function keys, which are representing the functions up on the screen here. I pushed the DMN button and that switched over to multimeter mode, and actually I heard a click inside when that happened. We have multiple pages of menus here, so DC amps, DC milliamps, DC millivolts. It's the third page that has AC volts, AC amps, and AC milliamps, so if you're using AC a lot, that's a little bit of an annoyance. You've got to go to the third page to get to that. But for digital electronics like me, I'm using DC volts, ohms, and the multimeter function or the continuity function literally almost all the time. So the fact is those are on the front page. It makes it easy to use. I'm just going to connect up some leads here so we can give this a quick test on continuity mode. Nice and fast. Cool. Now the update rate's not fast, but the beeping is certainly pretty fast. If we switch over to ohms and we short these together, oh, you know what, that's relatively quick. The update speed is really slow, but the auto ranging to go down to 0 ohms that's pretty quick. Now it's not very high resolution. I'm pushing various buttons on here to see if there's anything I can do to manually control the range. Like I want to put this down to ohms range. And it doesn't seem like any of the buttons do that. The direction controls actually change the function. So left and right changes the function there. Up and down doesn't do anything. I would think up and down should change the range, but at least on ohms, it does not do that. Pushing the AWG here. This model has no AWG. I think that's the function generator here that has a jack, and yet it's disabled. So that's explain, but oh well. Menu doesn't actually do anything in the multimeter mode. So it's a very basic multimeter from what I can tell. But ultimately, I'm not complaining. It works. It wouldn't be the main thing I would use this for. I mean, one of the problems is the screen viewing angles, not particularly great. So while it's running here in the oscilloscope mode, I gotta say, like, the refresh rate looks quite good. And that's pretty nice to see. Because one of the problems is with these types of handheld scopes is the update rate can be really slow. And while that's not necessarily a problem when you're doing measurements, it's just kind of annoying to look at. And I like the faster update rate. So I'm just gonna connect one of these oscilloscope probes. These are the same cheap ones that came with the other one. Oh, and incidentally, I don't think you can see the little screen on here. It's now charging at 1 amp, a little over 5 volts. So obviously it's got a little bit of intelligent charging going on. Okay, I have this connected to the function generator. Let me turn it on. It's set to 5 megahertz. What is that doing? I am just seeing a whole lot of nothing. Okay, so I push the trigger button and we have channel 1, channel 2, rising, probably falling, double. Okay, so it has a couple modes. Okay, we push up and down to move the trigger indicator right there. There's another page. Force, okay, we don't need to do that. Let's push the channel button, channel 1, enable on or not. We have a coupling button, so we have AC, DC, or ground. That's pretty nice. I'm gonna put that on DC coupling, but it's nice that it has AC as an option. We have a probe setting here, 10x or 1x. Ooh, we have a bandwidth limit. So on almost all scopes that I've seen, and the menu just disappeared, the bandwidth limit is applying a 20 megahertz filter to the input, which just really helps eliminate noise and ringing. Especially if you're capturing signals from like a 64, you're gonna get a lot of ringing when you're using like long ground leads and stuff like that. So turning on the bandwidth limit can really have a positive effect. Okay, so how do we adjust things on here? We're at 10 volts per division, left and right arrow. Okay, there we go. The trigger, let me move the trigger up. Okay, that's pretty easy to use. And then the purple here is the time base, 500 microseconds. So up or down? No, that just adjusts the trigger. Left and right? No. Oh, I just realized I have to push this time button here. Okay, and now we have mode. So we have roll mode. Excellent. That's what the other one didn't have either. And I love using roll mode sometimes. So we're going to switch. Okay, there's XY, which would be like a 3D representation using both inputs. There, we're going to use YT. Oh, it turned on the second channel, which I don't want. Channel 1, channel 2, off. Okay, I'm going to leave that on DC coupling. So we want channel 1 on DC coupling. 10x Pro bandwidth limit is off. Let's turn that back on. Okay, time. Now, does this change the time? Yes, it does. All right, so there's the waveform. Now, it's not triggering because it's kind of moving around. Now I need to figure out what's happening there. Source is channel 1, rising, falling. If I push channel and I push up and down, I can reposition the waveform on here. Now, a few things to observe. The update rate is really slow, but I'm also having trouble with the trigger. See up here it says triggered, it goes between TRID, which is triggered, and auto. It shouldn't do that. I don't see why it's not just triggering. So there's an auto button down here. I never use these. I'm gonna push that. Let's see what happens. Auto setting. Okay, it looks way better now. Don't know what was happening with the trigger there. So let's go to channel 1 and move this down. And let's change it to 1 volt per division. There it is. And we'll push the trigger button and I'll move the trigger point up just into the middle. Looks pretty nice. And I love how fast the update rate is now. If I turn off the bandwidth limit, there it is. You can see there's some ringing now visible there. And I turn that on, it gets rid of that. So I actually typically operate with the bandwidth limit on. Oh, let's look through the rest of these menus here. BL time, backlight time. Okay, the backlight shuts off. I'm not really sure I want that to ever turn off, so I'm gonna leave it on infinite. I guess you have a reference waveform you have access to. You can obviously save probably that waveform and call it up later. Oops. Aha, there are cursors and measurement. Now it's in the menu setting. Let's check out the cursors here. Enable. Where are they? Guess we gotta put, okay, cursor 1. Oh, I see, there it is. Okay, so right now we're looking at cursors that are along the horizontal plane here. So we switch this to time, and there's one there and there's one there. Boy, they're not easy to see. So let's see here, 400 nanoseconds. So how do we move this? All right, so this is a little fiddly to use, but there's a purple line right there. If I hold it, okay, that's good. It has acceleration, so that's good. So I put one right there, and I want to put the second one there. So you push that, and we're going to push this. Okay, and there's the increment. 1 microsecond, and that is correct. We're looking at 1 megahertz square wave here, and we're getting a 1 microsecond increment between those two, which is exactly what we would think. Now the menu went away, and I don't love that. I really wish there was a way to make this stay. Anyways, that works. It's a little clunky, but considering there aren't that many buttons on here, you know, it's definitely functional. I really wish the lines were a little more visible. There's a little tiny arrow up there, which I'm not sure that's even related to the cursor. Let's see if it is. Let me turn the cursors off. No. Okay, that's just the center point of the capture. So this up here shows the entire buffer of the capture, and the purple line here is the center and it's the trigger point. Now when I zoom in on this, notice how the waveform doesn't move around as we switch it. And that was a big problem with that $56 scope. As you zoomed in or zoomed out while changing the time base, it would move all over the place and you had no idea where the actual trigger point was. This thing, on the other hand, really does work as I would expect it to. All right, so we have 20 nanoseconds, 10 nanoseconds, 5 nanoseconds. And look at that, you're seeing that nice slope there? This is awesome. I saw a tiny bit of jitter on the trigger, but that's so stable. That's the way it should be working. And this thing works so much better than that really cheap oscilloscope. And then right here is the buffer depth. So this up here is the entire captured waveform. And with this set to 3000, it's capturing 3000 points. So what we can see, which is this part of the screen, is the little green part there. And when I change it to 6000, notice that gets smaller. And that's because it's capturing more data. But almost certainly it's going to take longer, or it's going to update more slowly when I'm capturing more data. But it just means when I pause this, so right now it's stopped, I can push the arrow keys and I can scroll around the stored waveform. So all of this is stored in the device, and there's the edge of what it's captured. Okay, so one thing I'm noticing, like, so when I had the cursor turned on here, like there it is turned on, and there it is, 1 microsecond. I kept complaining that it would disappear. Now I'm gonna let this time out. Okay, it's gone. I think if I push a button, it comes right back. It does, it goes right back to the last menu you were on. That's a pretty nice feature, I do like that. If it went back to the main menu, I'd be kind of annoyed. But the fact is, it just sort of goes back to where you were. All right, so besides cursors, we have measurement. So frequency, ooh, look at that. 1 megahertz right there, 1000 kilohertz. That would be something I would just keep on all the time. What does period do? Oh, there it is. So that's, I like that. I really like that, 1 microsecond. What else do we have here? Mean, max, min. So max 4.8 volts, minimum 200 millivolts. We have peak to peak. Looks like I can only turn on 4 things at a time. So that's okay. It's not the end of the world. You just have to pick exactly what you want. So let's get rid of period. And we're gonna get rid of min and max. Let's put on peak to peak, 4.68 volts. V amplitude, RMS voltage, duty cycle stuff. Yeah, like a decent set of parameters there. Software version is 2021-7.13, so relatively modern. Let's see what else we have in here. We have a shutdown, 5-minute shutdown. Calibration mode, which I think it said it has an auto calibration mode. Defaults, boot logo, off or on. Nice. Yeah, there was no logo, was there? Sound off or on. Yep, if you don't like the clicky noises. And that seems to be it. I didn't see a setting on how long the menu takes to time out, but now that I realize that you just push the button even when the menu has disappeared and it works, that is not so bad. This button says there's no function generator. I still can't believe that there's a jack and there's a button and it doesn't work. It's almost like it's a software thing. Let's see what else is in trigger here. So you can source 1 or 2, force, okay. It doesn't seem like for the trigger there's any kind of hold off or anything, so nothing much you can do about that. I'm gonna unplug this from USB power here, so it's now running on battery. Oh, the battery was dead because it's very low. Let's shut this off. Oh, actually the power LED is not red anymore. Okay, so it said saving. Now let's see how quickly this thing boots up, because that is a problem. So I'm pushing the button now. Okay, the light came on. Hey, that is a quick boot up, no logo because we turned it off. Well, it was off already. No funky noises, it just came right on. Really nice. I noticed that on restarting this thing that the measurement went away. So I kind of wish it didn't do that. I know I started jumping around here, but I was pushing on this person button, profile, whatever, and right away it says to recall defaults. But if I held it down, look at this, set custom function keys, and I pushed enter, and now it says save current settings to custom 1. Sure. So now when we exit out of this and I push that, well, that doesn't, I don't get it. I don't get what this is. Seems like holding down the profile button is the only one that actually does anything. Holding down anything else just makes it beep, but doesn't really do anything specific. All right, wait a second. When I pushed the profile button, it said saving. Saving what? Oh wait, yeah, I think I got it now. So I pushed this. Now it says press F1 to recall custom 1. So let's just mess up the settings a little bit. We'll like turn off the channel there. Push this. Custom settings recalled. There it is. Except now we've lost our trigger again. This is kind of like what it was doing before. There it is. Do you see that? It was set to channel 1, and I had to set to channel 2 and then back to channel 1, and then it worked. So let's turn off that channel again. No, that didn't do anything. Let's try restoring the settings one more time. Now it's working. Well, that seemed like that was the bug I was experiencing at the beginning, where it was not triggering, even though it said it was triggering on 1. But just switching to channel 2 and back to 1 seems to do the trick. Because yeah, there we go. They're not triggered now, but now we are. And you see it says triggered up in the corner. I'm just going to power cycle this really quick because I want to see if restoring the custom settings actually restores the measurement. So that measure thing is gone. Press F1 to recall custom 1. No. Well, there we go. I don't totally love that the measurement is turned on. I would really just like that frequency to be on there all the time, along with max. Those two things I'd like to see all the time. And here's a little bit of a trap for young players. So I'm looking at 1 megahertz signal, and look how it's just, I don't know, it's not doing anything that makes any sense, right? Now we're getting what looks like a square wave, but the time base is 20 milliseconds. So we're actually zoomed way out on the waveform. And this is aliasing we're looking at. This is not the actual waveform. And I'm pretty sure this is what was happening before. I didn't notice the time base was so slow. But because we should be going the other direction, and there, notice here, it goes from nothing not working there to this, which is like complete mess. Now, if we pause and we zoom in on that, we're gonna kind of see something that looks like a signal, but that it's not able to really capture enough data. But if we keep going down, 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 now we're starting to see something that looks like a waveform. Now I paused it. Now look, there it is. Now it's very low resolution because it was sampling only 3,000 points, and it's doing that across the entire buffer. So when we zoom in on that, we got a bit of a mess. But if we hit play now, there it is. Is I'm going to lower the duty cycle. So with this 1 megahertz square wave now, it goes up and it only stays on for 5% of the time as opposed to 50% of the time, which is what it was set to before. So now we can zoom in on this, and now we can see the rise and the fall all together. And of course we can move this over a little bit, zoom in again. There it is. Now I just unplugged the scope probe. Let's plug it into the virtual bench. Let's see what we see on this thing. And it just crashed. Now, of course, this is far easier to use, but there is that 5% duty cycle. There it is, 1 megahertz. notice the smoothness of it, and it looks very similar to how this thing looked. So I'm quite impressed. Let's turn off the bandwidth limit. There it is, we got the ringing, although the rise and the fall now is more sharp, but this ringing where it overshoots and undershoots is due to my long ground lead and all that kind of stuff. Switching back to the Hantek, I'm gonna turn off the bandwidth limit on this, which should be under channel, bandwidth limit. There it is. That looks so similar to how the virtual bench was looking. The more I use this little oscilloscope, the more impressed I am with it over this $60 USB scope. And it's really just because this thing was just on the margin of working well at these frequencies that we're using here. But this thing is really capable and it looks nice. It's got a really fast update rate. I mean, what can I say? This thing it's pretty great. Okay, I think I've done enough fiddling around. Let me grab the 64 and let's look at some actual signals on this oscilloscope coming from the 64. All right, I have a C64 on the bench so we can give this thing a test on a real computer. Now, one thing I haven't mentioned is that it didn't seem like there was a way to do the probe compensation on this. I think pretty much every oscilloscope probe, at least 10x and greater, have a little adjustment on them for adjusting the probe compensation. I don't know what that means technically, but I know that you need to do it. Most of the time on an oscilloscope, there'll be a little test terminal that you would connect your probe to, and then you would see a square wave on the screen and you adjust that until it looks square. Well, did you notice on this thing, it didn't appear that that test terminal existed anywhere. Like there was nothing in here, and I don't see that type of terminal anywhere else. But I just had an idea. What about this extra arbitrary waveform generator connector right here? It says gen out. Let's stick the probe in there. Look at that. And there we have it. It says 1 kilohertz, which is correct for this type of adjustment. And notice here, these little curved parts, that shows us that this probe is out of adjustment. In the bag with the scope probe, there were little bits and pieces, and one of those was an adjustment tool. I don't have that handy, so I'm going to use this little ceramic adjustment tool. And notice as I turn it, oh, by the way, the trigger point is not right. Let me fix that. But there it is. When we turn this adjustment, it goes one way, goes the other way, so you just want to have it as flat as possible. The fact that that BNC actually has the 1 kilohertz test signal on it might have been mentioned in the manual, which I haven't actually read, but it's a little weird that they didn't just replace that with a little metal hook lug, which is what's typically on every other oscilloscope I've ever used. All right, I think we are good to actually try this on the 64. So the first thing we want to do is hook up the ground lead up to the machine. Now, this little clip that's on here isn't normally what's on here. In fact, typically there's just a little alligator clip on the end. What I typically like to do is connect a longer clip lead on here that has a hook on the end. It's just easier to hook onto things. Now, this is not good for signal integrity because it's going to create overshoot and ringing and stuff like that. But for low speed measurements, like what we're going to be doing here, it's completely fine. So for proper measurements, of course, you have to hook an oscilloscope up to ground of whatever you're measuring. So I'm going to clip it right there on the edge of that inductor, which is going to the ground plane on the 64, which is this part right here. Now, of course, since the screen is small on this, I have to keep the camera relatively zoomed in so you, the viewer, can see it. But the computer as well, we're not going to be able to see the whole thing here. So I'm going to use the other camera here to hopefully show a little bit about what I'm doing. So let's just start measuring, let's say, on one of these RAM chips here. All right, notice how this is going off the top. That's because I have it at 500 millivolts. Let's change that to 1 volt per division. Now the waveform we're seeing is all just munched up, and that's because I was measuring a 1 kilohertz signal. So we need to now adjust the time base here. I'm just gonna adjust the trigger point up a little bit, not that it matters necessarily. Well, I just disconnected my clip lead here from the ground lead, so I have the ground connected directly here because I was just getting some noisy results. And I've run into this kind of thing before. If you don't have a good solid ground connection when you're probing with an oscilloscope, you're gonna get noisy results. And a good way to test that is just take the oscilloscope probe and touch it to the ground itself. You shouldn't see any interference. And just now when I had this connected to there, I did have interference. It looked like maybe 60 hertz from the LEDs in my shop. I think what's going on is this alligator clip here is really, really corroded. And I think this hook is also a cheap one and it's sort of falling apart. So I'm not gonna use that for now. But in the past, I've had these ground leads actually fail, and I know I've complained about this on videos before, and when that happens, you get bad results as well. But with the proper ground, when we take a look there, now we're seeing a nice good signal. It's going up the full amount, and it all looks right. So just poking around the various signals we see on the RAM chip, everything looks good. Now, this computer actually works, so, I mean, of course, it's gonna look good. All right, well, I said this machine was working, but I'm just getting a black screen now. I'm getting the line on the side. It was literally at the blue screen a moment ago. When we look at the 6510 right here, it is pin 40. That is the reset pin. That's the top one right here. So why don't we look with the oscilloscope at that? And I can't, right? Because this ground lead is not working. So I'm gonna move this over to the RF shield here. And on the reset line with the machine powered up, it is high at 5 volts, which is what we would expect for an operating machine. When I turn it off and back on again though, it should stay low for a moment before it goes high. This is after I turn the power on. Okay, and it's actually doing exactly what I said it should. And guess what? The machine is working again. So I'm not sure what was going on there exactly. That was weird. But when a machine doesn't boot up like that, it's always important to check the voltages, the reset line, and the clock signals. Because without those 3 things, you are not gonna have a working machine no matter what. If we didn't see that reset line go low first and then go high after a little bit of time, what can happen is when you first power up the computer, things start to execute right away, like the CPU tries to start running before everything is necessarily powered up on the machine. So it's really best practice to keep reset low for maybe half a second, and then it goes high, and then that makes sure that everything on the board comes out of reset at the same time and is ready for the computer to boot. All right, while we're on the CPU, let's take a look at Phi 2, which is the clock signal. And there it is. If we go into the time setting here and we zoom in a little bit, and there's the clock signal. It doesn't look perfect, but of course, maybe my ground lead is not set in the right spot or whatever, but this obviously is enough for the computer to work, and the clock is around 980 something kilohertz. It's jumping around a little bit, and that's normal. This is not the most accurate frequency counter, but it gives you an idea that the clock signal is decent, and that is correct. It's a little bit less than 1 megahertz is what the 64 runs at. All right, so now what we're looking at is the read-write line. And anytime the signal is low around 0, that means the CPU is trying to write to RAM or some other device, where that device that's selected needs to look at what's on the data bus and take in that data. Otherwise, it's reading. So whenever it's up at 5 volts here, it means the CPU is reading from some component on the computer. And you can see it just sort of jumps around a whole bunch. Now, if I turn the computer off, like it is now, and I turn it back on, notice how there was really no activity for a little while there, just for a split second, and then you saw one jump, and that was it checking the RAM, or jump to 0, and then now it's just general activity, which is normal for a 64 while it's running. Now the next pin down is the data bus. Now it looks like it's a lot more activity in the read-write line. Oops, I just fell off the pin. Let's go back on it, there it is. And that's because the VIC2 is talking to the RAM, and there's a lot of activity going on the bus that's not just the CPU accessing stuff. Let's zoom in a little bit on that. So we go to time, and we see the activity. Now, if I pause this, when we hit that pause button, notice there's this part here that looks lower, and over here, that part that looks lower. That's still fine. TTL is low when it's like from 0 to, I think, 0.8 volts. That's considered low. And anything above that is considered high. And that can be one of the issues when you try to mix and match CMOS type chips or different types of chips together with the TTL chips that are on a 64. Then it's quite possible that something that might be lower than maybe a CMOS chip would like might be counted as a 0 when a TTL chip would count it as a high. So there are subtle differences between TTL and CMOS that can cause incompatibilities in some situations, and you're seeing it right there. Because we're at 1 volt per division on this oscilloscope right now, that is currently at 1, 2, 3 volts, that lower down section. If I pause it, see that's around 3 volts, and that's at 5 volts. And again, in the TTL land of a 64, that's just not a problem. All right, I've jumped all the way down to address line 15, which is the top address line on a 6502 or a 6510. In this case, that's a 64K address space. Notice it has that curvature going on. It's kind of indicative of a pull-up resistor, which I think is on the address bus, or at least some of the lines on the address bus. In fact, let's jump over to the other side of the CPU here and look at one of the lower ones, and notice it doesn't have that curvature. I think there is no pull-up on those, but these ones, the higher address lines,
have a pull-up resistor. When you look at a 64 and you see that curvature there, that is actually normal. As long as you're getting good solid lows and good solid highs in there, that's fine. But if the address lines are floating at any given time, then a pull-up resistor, a high value pull-up resistor, will just slowly pull it up all the way to 5 volts. But if it goes quickly, like you're seeing right here, that's because it's being driven to 5 volts or driven to ground by an IC. All right, one more thing to look at. Let's take a look at the Luma signal on the VIC-2. And there it is. That is one scan line on the Commodore 64 between there and there. That's the horizontal sync pulse, and then it goes up, and then that's the actual video signal right there. You notice how it's changing constantly? That's because the scope is sometimes triggering in the border area, where basically you're seeing a solid blue, or when it drops down, that's the darker background, and then where it jumps back up is the text. Now we're just triggering on random scan lines, that's why you're seeing that. And occasionally it might actually trigger where this whole part is missing altogether because you're in the vertical blanking part of the picture where there's no border either, it's just black. But you can see right here the scan rate, 16.65, and that is because this is a PAL machine. And that is the scan rate of PAL. The next pin up is the color output. Now notice it's like way off the top here, so I'm going to change this to AC coupling, which should bring it back down again. If this were an NTSC machine, we'd see the color burst, which is like 3.45 megahertz or whatever that is. Let's zoom in a little bit. There we go. Actually, that's showing us the color carrier frequency, and it's 4 point something megahertz. Well, 4.43 is what PAL actually is. So that does give us an idea that we are definitely looking at a PAL machine here. There's one more thing I want to mention about these handheld scopes. It's not unique to this one, but it's just one of the benefits of having one of these. That's something I haven't had up until I got this one. On a regular bench oscilloscope, including this virtual bench here, it's plugged into the mains AC power. And that means that everything on this that's grounded, like these BNC connectors, or even the ground lead here when you connect it up to this, is actually referenced to earth ground. That means you have to be very careful what you connect the ground lead to, because if I connect this to something that's actually referenced to the live or the hot line, it can create actually a short circuit. And well, something like this, obviously it's battery powered, so it's not referenced to anything at all. Now, of course, the caveat is if you plug the USB cable into that, then this would suddenly become ground referenced to my PC, which is earth ground referenced. So that's not good. I mean, it's possible that it actually is isolated. I don't know, like a really good design, the USB port would actually be fully isolated with optocouplers, and it wouldn't be connected to this ground outer part of these BNC jacks. Actually, let's give that a quick test. So I grab this USB cable, well, it's two tied together, and I have the oscilloscope probe plugged into the top here. Let's grab the multimeter and set this to ohms. We'll connect this to the ground lead on the oscilloscope probe, and let's just see if we have continuity. Look at that, we don't. So the benefit of having a scope like this is you're actually safe, you know, if you do it properly, to connect this up to things like inside a television set where it's a live chassis without potentially creating a short circuit. There is still potential danger because these metal shrouds here on the BNCs are almost certainly all connected together. So if the ground lead on the probe is connected to something that's high voltage and it's a reference to the mains in the house, then yeah, if I touch one of these with my hand, I can get a shock. But they are recessed inside of here, so even if I hold it like this, I mean, my hand is close to them, but it is not touching them. The safest thing would be if there was a plastic cap to install on top of these if I wasn't using it so that I wouldn't accidentally brush them. But they're still far out of the way from where your hands would be if you're interacting with the interface on this device. Now, all these things I just mentioned are the same with all battery-powered portable type oscilloscopes. And because people are going to mention it in the comments, I will just mention it here, that it is possible to create that similar isolation safety by using an isolation transformer, either putting like the bench scope itself on the isolation transformer or the device under test on the isolation transformer, which separates the reference between like the mains and the earth ground from the device you're testing. So that creates that safety. But using a portable scope like this is just a quick and easy way to do that without needing an isolation transformer. Like say I'm working somewhere where I don't have access to one, well, I could bring this thing with me and still get that safety. So there we have it. That's my review of the Hantek 2C42 portable battery-powered oscilloscope. I'm really quite impressed with this thing. Great build quality, pretty functional. I wish the UI were a little more streamlined, but overall, I'm actually pretty pleased with this thing. Couple things I've noticed in the time I've had this, because the first part of this video I actually recorded a little while ago. The standby time on this when you shut it off isn't great. I think there's a lot of parasitic draw on this while it's turned off. That could be a little bit better. But this device does use very easily user replaceable 18650 batteries. So if they get overdrained and are damaged by this thing not being used and being turned off for a long time, you can just swap those out without any problem. But from a capability standpoint, I think I've shown that this thing is very functional and works as well as any of the low-cost oscilloscopes that you can buy for your bench. But I think for like the $112 I paid, or $115 or whatever it was, it's really quite a reasonable thing. This device is so much better than the $60 scope that I reviewed on this channel last time. But of course, it's twice the price, so it better be a lot better. And the fact is the screen is really small, and even for me, you know, my eyesight's not super great anymore. Like, I do need stronger glasses. That I actually prefer using the PC just because it's larger screen, it's easier for me to see. But the thing is, I really did actually need a portable scope, so this thing really fits the bill perfectly. Now, I will have to mention that I know there's another scope that's in a very similar price bracket to this from OWON that actually seems like it's better in some ways. It seems to have a better, more capable multimeter, has a larger screen, and it potentially has a few other things that are better. Although I think that this is better in certain ways. So it's sort of like it's give and take when it comes to which is the one you would want to get. I'll put a link to the OWON scope in the description as well as this one. So cross shop them both and figure out what's better for you. If I hadn't already bought this and I were gonna buy again, I'd probably get the OWON scope because the bigger screen's a bit of a draw for me. But honestly, I'm not sure that really matters because I am very happy with this thing. I think this is a really, really good device, especially for the price. So that's it. I hope you found this interesting. If you did, I'd appreciate a thumbs up as usual. I do have merch now, so there's a link in the description to that. I haven't really launched it yet. It's just sort of a soft launch, but you can pick up a t-shirt. That's what's there right now. Thanks to my patrons, their names are scrolling up the side of the screen. I really appreciate the support for them. It allows me to buy stuff like this and other things to keep the channel going. So I really appreciate it. And if you want to become a patron, there is a link in the description. Check out my second channel if you haven't already. Lots of cool videos over there. And I guess that's going to be it. So stay healthy, stay safe, and I will see you next time. Bye.